Basveshwar Engineering College, Bagalkot, and ME CS and IT from Bengal Engineering and Science University, IIEST Shibpur, where Sir has secured second position to the university, and PhD from IIT Kharagpur. Sir is with 25 years of teaching and rich research experience. His areas of expertise include speech and image processing, human computer interaction, machine learning algorithms, and cloud computing. Sir has authored 2 books, 8 chapters, over 45 journal papers, and more than 130 conference papers. In addition, Sir has filed 5 patents, 3 of which are granted, successfully completed 6 DST-sponsored research projects worth of around 2 crores, and guided 10 PhD scholars, with 6 more currently ongoing right now. Dr. Koolagudi sir is also an active member of professional bodies such as IEEE, IST, ACM, IE, ISCA, and CSI, and has been an invited speaker in more than 100 national and international workshops and conferences. A significant achievement is that he has been declared among the world's top 2% scientists in his field of research by Stanford University for from 4 consecutive years since 2022. So today, sir will be delivering the session on sustainable speech technologies for modern applications. We are truly privileged to have you, sir. Thank you, and we now I hand over the session to you, sir.
Thank you, madam, for the nice words said about me. So, good evening to all participants. Today's topic is a broad topic which was given by ATAL, is emerging trends in AI and smart innovation sustainable technologies. As my area is speech image signal processing, I have chosen to speak something about sustainable technologies in speech technology. And also, as it starts with machine learning and artificial intelligence, I'll touch upon some fundamentals of machine learning, in what way we are using that, and is it the right way that we are using, something like that. This is a kind of chit chat kind of a thing. Don't take very seriously the things, whatever I'm going to discuss. Be encouraged enough to ask questions anytime in between. Share your experiences. Similar kind of thing. Then the purpose of this workshop will be more fruitful, is what I feel. So, first, we will. I'm from NITK Surathkal, as Madam said. We will see 1 or 2 slides about what my organization is. So this is I think you're seeing the cursor which I'm moving. The left side of the building is NITK Surathkal main building, which you have seen on website and many other places. Right side building is new computer science building. NITK started in 1960 as KREC, Karnataka Regional Engineering College. While we were studying our PDACEK, everyone has got a dream of entering into this institute. Computer science we have started in 1986, and KREC has become NITK in 2003, where central government took this, and it became the institution of national importance. Recent NIRF ranking, which was announced yesterday or day before yesterday, gave us 17th rank in the country. And one more specialty about NITK is we got all our undergraduate programs 6 years accredited in cycle 2, that the OB cycle of NBA accreditation. We are told by NBA committee that NITK is one amongst top 2 institutions in the country who have got this kind of achievement. As a Department of Computer Science and Engineering, we are floating 1 UC program, 2 post-graduation programs, and PhD program. Recently, we also have started part-time PhD program. In the department, we have 19 members now, 19 faculty members, working in the different fields like networks, medical imaging, speech processing, underwater communication, cloud computing, whatever area you name, they're experts in the department. We have world-class infrastructure which is open 24/7 to all the students. So the purpose of telling all these things and showing this slide, I think you can guess this is a rich green forest. Can anybody guess what you are seeing after that forest here, which is bluish color? Please speak whenever an opportunity is given to you. What is this bluish region?
I guess it is a sea, sir.
It is Arabian Sea. Exactly correct, sir. It is fine. This is a photo taken from the corridor of our department in front of my cabin. So at least I invite all of you to come once whenever you come this site to visit NITK and see this beautiful natural things, nature. Coming to the topic, just some slides lightly I have, very lightly I have added to this. Today we have reached an era where our young scientists, students, graduates, whoever is, have reached a stage what is shown in this cartoon. Here a person is sleeping, morning he want to wake up, he wants ChatGPT to give a good reason that why should he wake up, or what are the tasks that he has to do today. This much dependency we have on ChatGPT, even in education institutions. If you give assignment, people refer to ChatGPT and submit the assignments. If you go to industries, people do meeting and to prepare minutes of the meeting, they depend on ChatGPT. Programmers in computers industry, for the basic code generation, they are dependent on ChatGPT. So for recommender system, if you want to go to movie, we are dependent on ChatGPT. How regarding recommendation for movie. So anything and everything you say, majority of the world, at least developing world and progressing world, is dependent on computers and its technologies. Once I say computers and its technologies, I am mainly speaking about artificial intelligence and machine learning. Artificial intelligence is a very broad umbrella which we had studied in 1990s at Align Rich book, which is very classical way of thinking that how an artificial intelligence can develop. But if you see today's machine learning, altogether it has developed in different dimensions. Whatever we had studied there in the theory, that blue color Align Rich book, where it's talked about A star algorithm, EO star algorithm, hill climbing application algorithms, annealing, all these approaches, best first search, these are the things we had studied. But the way the machine learning developed today is totally altogether in a different way. We will see that later. So I want to touch upon some basic understandings of machine learning and AI also, so that I can relate the things here in this given topic. Earlier, when machine learning was not a very big term in industry, maybe early 2000s or late 90s, 1998, 99, the field started taking slowly the shape, but people were not sure of in the next 20 years or 15 years it will grow in such a tremendous dimension. Whenever some new jargon people used to hear, management used to force their workforce, why don't you use an artificial intelligence or machine learning kind of thing in your production cycle so that it can be more efficient? That's what this slide says. Boss was asking, so our VP heard about machine learning and wants us to add it to everything, day-to-day activities of the production line, software development line, whatever is that. Can you lead that team or effort? A boss is asking his subordinate. She is telling machine learning. That's not exactly my area of expertise. People were so ignorant, so what light about the term machine learning, because at that time just it was coming into, and even without that people were doing very nicely, and they were not able to imagine a dimension of scalability that they can get because of machine learning. So machine learning was just thought of. People were not very serious about that, and slowly the days have changed, and it started entering into all fields of life, including software development. Earlier, once we say automation only was for the production industry, like shop floor, where there is a very high temperature, human beings cannot go and see the parameters there. Then we designed a robot can go there, check the parameters and tell what's happening. So the process of automation started like this, to venture into some machines of technology where human beings, it is not advised or it may be fatal sometimes to venture into. So that way automation started. Now automation has uh, say that as it has exploded everywhere. Anything, any aspect has been automated. Even we don't want to rise from our place and switch off or on the fan, so we want remote to switch off or on a fan. Already remotes have come to switch off on, change the channels of TVs, anything. uh, Smart home you might have heard about. Anything and everything is done through passing certain signal through one small device, which made the majority of our day-to-day activities automated. So machine learning started growing more relevant, and it has become inevitable. And many old people were not knowing about the technology. And what obviously they thought in their mind was all machines are to be kept as students, and one teacher should teach them. That's what machine learning is. The concept earlier people thought of in late 90s, early 2000s. So machine learning means a computer, laptop learns, and a teacher should be there to teach that. You might have heard this name. Herbert Simon is one of the pioneers in machine learning, who gave so many concepts. There's a book also, who gave so many concepts about machine learning. You might be knowing what is the highest award given in the field of computer science. Very prestigious highest award. Please keep responding whenever I ask some questions. Am I audible?
Yes, sir, audible.
Yes. So, which is the highest award in computer science? Highest award in computer science, which is given today, is known as Turing Award. Alan Turing Award. Yearly once it is given. There was a scientist in the field of computer science, especially this formal computation. In VTU, there's a subject called as FAFL, Finite Automata and Formal Languages. So in that, we have a reference of Alan Turing. He designed a Turing machine. This Turing machine is the design of the Turing machine is exactly same as today's modern computers work. It has got a memory, it has got a processing unit, it has got an unit, output unit. With the same concept, Turing machine was designed in 1940s, 30s, 40s. At that time, he could think of all these things. Probably at that time, even your electronic computers were also not there. It was the time of EDVAC, ETSAC. Partly mechanical computers were becoming electrical computers, kind of a thing. Later in 60s, 70s, 60s, 50s, this vacuum tube based computers came. Then IC chip based computers came in 70s. The technology grown as per the, who is that? Or what is name? Moore's law, as per Moore. every 18 months once the density of the transistors gets doubled. So all that thing went, and that Herbert Simon was awarded in 1975 Turing Award, Alan Turing Award, which is which says that he has got a very good contribution to the field of computer science. And in 1978, he was also awarded Nobel Prize for Economics. So he was equally worked in general scenario also. So this Herbert Simon defined artificial intelligence or machine learning long back. There are two definitions given for your help here. One is the first one you can read just like that, and Herman Alexander Simon. Learning is any process by which a system improves performance from the experience. Small child, if we say learning in speaking, then many mistakes that child does, many imitations that child does, many feedbacks that child takes. And as and when child becomes 1 year old, 2 years old, 3 years old, its language understanding capability increases, and the child is able to perform in a better way because of its experience. That's what learning is. Machine learning is concerned with computer programs that automatically improve their performance through experience. This is completely a new concept at that time once he had defined it. Means at that time, still that was an era of procedure-oriented programming approaches. If we have a task, a program has to be written for that task, and whenever you run that program, the possible input that program gives you expected output. So that's what at that time in 70s we had all the programming languages which are application specific, task specific. If something is some automation or something is to be done in industry, then COBOL would have been more preferred programming language at that time, common business oriented language, because it has got all options which help a person to write programs or solve problems related to business. Likewise, we have scientific applications, we have formula translation. Basic understanding of computers, we have basic programming language. Likewise, we have algorithmic logic. Different kinds of things were there at that time, programming languages. They used to help the programmer to write a program to solve a particular task. Means that program was a dumb entity which takes an input. You had given certain instructions. These instructions are executed, run, and the input is converted to other form. 1,000 times you run this program also, there is no improvement in the performance of the program, because this is basically a sequence of instructions. Same instructions are repeatedly executed dumbly. But the definition here, if you observe, slightly it is different. The computer program that automatically improve their performance. Means a program which you are running to sort a list of 10 numbers over a period of time. It should learn from the situation, observations it has, and it should make improvement by itself, and there should not be some typical errors which it normally commits otherwise. And this improvement comes because of experience. Maybe it is very difficult for us to digest now if we do not have little understanding of machine learning and artificial intelligence, but we'll see them later. So a first person or a person who strongly said something about machine learning very authoritatively was Herbert Simon way back in 70s. See here there's a slight difference between or there's a comparison between what is traditional programming and machine learning. In traditional programming or the programming what we teach in our first year to the students, write a program to sort list of 10 numbers, then you have a program, give a data unsorted list of 10 numbers, run this program, you get sorted output. This is the way. That's what the first part says. A data is given, program is given, computer runs both of them, and it gives you output. case of machine learning, what happens? Data is given, output is given. If this is an unsorted list, then its equivalent sorted list is this. Sorted list is also given, unsorted list is also given. Such several examples are given. Then your machine should generate a program wherein whenever an unsorted list is given, it should generate a sorted list. This is machine learning. So machine learning, what we tell is, for these problems, these are the solutions. Computer learns it as a pattern. If this pattern is input, then this pattern should be output. It learns it. Then anytime, whenever during testing, particular kind of a pattern is given, accordingly it produces some possible solution as a pattern. That's the difference. So data and output, if we give, program should be generated by computers. Whenever we had started our early teaching career, we used to ask one question always in the first year classroom or even second year classroom of computer science students: who is better, computers or human beings? What was the normal answer for this? If I ask today that question to the attendees of this workshop, who are better, computers or human beings? The answer? I have a doubt which is better, isn't it? Who are better? Any answers? Keep speaking, otherwise I will not be understanding whether I'm reaching you or not. And even I will not be understood whether I'm heard or not.
Sir, computers are better, but without human monitoring them, that will be
Monitoring.
useless, or controlling them or whatever.
Okay, very good. Computers are better than human beings. Nice answer. Any other answers? Thank you, Supriya madam, for that answer. Any other answers? Anybody who wants to say that human beings are better than computers because human beings have created computers? No one says that.
Sir, I would like to say that human beings are much more better because of them only all the everything, whichever thing is coming into existence, LLMs, anything, we are creating it. The human mind is creating it. That's why it is getting done. If
Very
you take into consideration ChatGPT also, the latest version also, the database that has been inputted, or else the learning machine that has been created, for that also till 2023 the data has been inputted. If you ask beyond that, it is just going to give you an ambiguous data. It is not going to give you a precise and confined data.
nice.
So whatever you take into consideration, always the human brain is above all, to my thing.
Nice. So
It can be precise, it can be the computers, whatever the language, whatever the platforms, they can be very competitive. But till you don't give them a precise command, they are not going to work for you.
nice. We may expect some good debate here, but let's not get into that debate.
I know. I totally agree with you.
Yes. So the same question when I asked in the class around 10-15 years back, students, even though if students are puzzled, so very confidently I used to say that whatever Fatima madam has given that answer, human beings are much better than computers because all computers are developed by human beings, programs are developed by human beings. So today's computers are working the way they are working because human beings have done them to work like that. But now in the class, I ask the question, but I do not have confidence to give answer like this. The scenario has totally been changed. All of you might have heard in 1996, there was one program, all seniors might have heard about it. There was one program which defeated chess grandmaster at that time, Gary Kasparov. Do you remember that? What is the name of the program? One computer program has defeated Gary Kasparov. Gary Kasparov was a chess player and he was a grandmaster. Grandmaster means best chess player in the world. Computer program has defeated him. Anyone remembered what's the name of that program? If anybody has learned AI or taught AI, then they must be knowing that. The name of the program is Deep Blue. You can recollect Deep Blue. 1995. Once that Gary Kasparov played with the Deep Blue, he defeated the program. He defeated the computer. And this computer scientists took all this feedback, why computer program is defeated and how, in what way it can be improved, and they did all the things. In 1996, again they invited Gary Kasparov to play against it. 1996, Deep Blue computer program defeated Grandmaster. That time itself a threat started that one day computers may become more powerful than beings. Now you may be astonished. Again, always there will be debate. That is fine. You may be astonished to know that by 2000 or 19, by 2029 or 30, we have on this, there is one computer whose knowledge is equivalent to combined knowledge of all human beings on this earth. There's one computer whose knowledge is equivalent to combined knowledge of all human beings on this earth. So do we have confidence to go and say in the class that human beings are better than computers? It is very difficult. It's very difficult. I don't know whether it is for good or bad, but we have reached a situation where any aspect you take, human beings are better than computers now. In the speed, they are better. In retrieval of the stored data, they are better. In storing and remembering the things, they are better. In processing, they are faster. In making decisions, they are better. Every aspect in wherever, in cleaning, robots, in cleaning, working in factory, shop floor, assembly, everywhere they are better, precise compared to human beings. Some part of human brain is still innovative and we are doing something. Maybe that is very, very, what I can say, negligible component of the population what we have today. The computers are much more better. So whenever this machine learning started grabbing or spreading its branches to all fields of life, then people started believing that AI computers are better than human beings. So bosses started making a statement like, his decisions aren't any better than yours, but they are way faster. Whatever decisions computers make, whatever decisions human beings make, people started comparing them. They reached to a status or conclusion mindset that decisions made by computers are almost similar to decisions made by human beings, but they are taking those decisions much faster. Much faster. Say, you might have also heard about expert systems, which were very popular in late 90s, where these machine learning algorithms were very popular. There were some rule-based algorithms, which based on certain rules used to decide what is to be done. Those were called as expert systems. We have expert system for medicine, we have expert system for legal cases, we have expert system for many such things, where how does a doctor normally detect a disease in you? When you go there, he touches you, he checks the temperature, he checks the pulse rate, and he checks some body vitals like your blood test or whatever. Then based on his experience, he takes a decision that this has happened. Probably we may have to go for this medication, or we may have to go for further testing. So can machine do this? Rule-based systems were developed, which were called as expert systems. These expert systems were capable of making decisions better than human beings, or almost equal to human beings, because it was working based on rules. If temperature is greater than 98.6, then the person has got fever. If this is this, this is this. If this is a blood test, and these are the vital parameters. If these vital parameters are not in this range, probably dengue. So all these decisions computers can make much faster than and much efficient than human beings. So that's what people started seeing the future scope of AI or ML in the field of engineering industry. But now, if you take the term machine learning, this, you cannot imagine a field where machine learning related outcomes are not there. So you can think of information theory, you can think of statistics, you can think of medicines, you can think of neuroscience, physics, statisticals, maths, anything and everything. You have role of machine learning in that. So it has been spread everywhere in our lives. This is called as world cloud. Here, darkness and size of character decides influence of machine learning in that application. If it is more darker, bigger character, then ML influence in that field is very high. Say for example, computer vision, ML influence is very high. Image processing, ML influence is very high. Medical diagnosis influence is very high. Bioinformatics influence is very high. So likewise, if you see here any area that you take where research is happening today, all those fields are there and all of them have got higher or medium or lower influence by machine learning approaches, machine learning applications. As I said, machine learning, here the programs are written in such a way that they learn from the examples, then they improve their performance. So normally in machine learning, we have some steps. All of us know this. Just you see the sequence of operations there. First, we collect data of anything that we want to do, because here machine learning algorithm becomes more perfect by seeing more data. So higher the data, your machine learning algorithm's outcome is more generalized and it is better. So huge amount of data you need to have. So first gather the data. Then all this gathered data is not ready for usage. There can be so many pitfalls. Some of them may be out of range. Some of them may be irrelevant values. Some of them might not be values at all. So pre-processing has to be done, which we call as preparing data for machine learning applications. Then choose a model. In machine learning also, machine learning is basically purely maths. Different mathematical algorithms are used to make machines learn. Machines here, I mean computers. So we have Bayesian theorem. Bayesian theorem can be used to make machines learn. We have Gaussian mixture models. We have support vector machines. We have so many similar things like Markov chains. So all these things will one or the other way influence the process of machine learning. So which model we want based on their relevance and their advantage, we need to choose model, mathematical model. Then this is the data, this is a model, train this model on this pattern. Data means it is to learn a pattern that's embedded in that data. So using that data, using this model, training is given. Then machine knows what kind of pattern it is. Then you have to evaluate whether whatever machine has learned, whether it has learned properly or not. Give some test data and see what it predicts. Whether it is properly predicting or not, you know. Then you can decide machine has properly learned or not. Then some hyperparameter tuning to make machine understand in a better way the data. Finally, prediction of the unknown data. These are general steps in any machine learning applications, whatever it is, either it's speech learning, speech processing, or it is biomedical image processing, or it is rocket science, anything, whatever it is. These are the steps always to be followed. These are the same steps. Let's not worry about this. Normally, data are collected using sensors. Then these are stored in some place in servers. Then these are pre-processed for removing some abnormalities and making them ready. Then on the servers itself, these machine learning algorithms are run and trained. That testing is also done on the server. Same slide. Basically. Then the question arises to give certain proper situation why machine learning has come into picture, how it started, and what is its present state. All these kind of things. This is a very favorite slide of mine where I explain wherever I go. That is, India is a very big country with lot of population. Earlier, if you take one domain like healthcare domain, we have community medical facilities. Means one hospital for the entire village. Then people used to go there, get treated. For this activity also, doctors were not sufficient. Lesser number of doctors. Then for doctors to be worked in the rural areas, that is made compulsory. Now that is working. But now, case is not like that. We are in need of personalized medicine. Personalized medicine in the sense, my body is totally unique. You cannot treat my body based on some values you have as average values. Say, for example, what should be the sugar level if you want to declare a particular person is diabetic? I'm asking very simple questions. Please be responding so that it will be more fruitful. I also feel like I have to speak something. What is sugar level? The person is to be declared diabetic as per doctors. Not hearing. Somebody is trying to speak, it seems.
Sir, diabetic or pre-diabetic?
Pre-diabetic, you can take diabetic. Just it's a very what
120
120
till 120
120
to 140.
It is very loosely put question. Don't think that I'm a doctor and very precisely asking this question. So whether this 120 is it as per, because I'm a human being, my food practices are different, the place where I stay is different, the work what I do is different. Seeing all these things, whether this 120 has to be a mandatory parameter for me, for the doctor to decide whether I'm pre-diabetic or diabetic, something like that.
No, for
Logically,
this
it's
also,
yes, madam.
no, for this also they take an average of 3 months
Hmm.
so that it is uniformly safe for, it is a deciding factor. HB1AC test is there. For that, they take into consideration the average of 3 months and then they decide for it.
No, correct. What
Because
I'm asking
random blood
is
sugar is different, because there are so many things. Random blood sugar
correct.
is different. Fasting is
Correct.
there. After fasting, after post lunch is there. There are so many things that can be considered.
Correct.
But
But
122, now they have given a higher end to 150.
what I'm asking is, from where did we get this value 120? Why is it not 110? Why is it not 140, 150 as you're telling recently they are considering it 150? From where did we get this 120 or 130, this value? This value was probably given by some doctors who had taken some 10,000 or some 20,000 patients and did some survey. Probably they might have done this survey in a cold country like America or UK, wherever. Then they said that if your blood sugar level is crossing 120, probably you're pre-diabetic or diabetic.
Yes,
And
exactly.
that they published in some journal, and our doctors read it. And even in tropical regions, like hot regions like India, Africa also, irrespective of what we do, how much automation our society has become, how much labor work we do, even if a farmer goes also, they take 120 as a standard. And even if a software engineer who sits for 10 to 12 hours every day without moving on a chair is also taken the same standard. Is it right? Definitely, for the better treatment, this is not the approach. That's why now the concept has come, which we say as personalized medication. my lifestyle, my condition, body conditions, sugar level may be different. For some other person, it may be different. So if that way it happens, then for every human being in India, there should be a doctor. It's not possible. Then we can think of making use of machines for this purpose. That's what in all your watches now. Your watches are the good doctors now. They measure your heart rate. They measure how many steps you have walked. They will tell you are exhausted now. You don't walk. You take this medicine, that medicine. All those things they will tell, isn't it? So this is because of advent of machine learning into day-to-day applications. So now, as the usage base is more widened, then human beings cannot perform there. Scalability in case of one doctor, how many patients can he see? Day and night, if he sees also some 50, 60, 100, 200 patients, he can see. And if he goes beyond that, his efficiency will go down. The doctor will lose his health and he has to go to another doctor. But if machines are adopted for that, there's no such problem. So now India is moving slowly towards personalized applications like recommender system. What kind of food I need, I can ask my computer. What kind of cinema I want to see, or what kind of songs I can hear. All these things are based, I will hear, are based on my past history. So studying this past history, computer will recommend you, these are good songs for you. This is a good movie, you can go and see that. So that's called as personalized approach. That's one thing. Another means these are the needs of the day. That's what your machine learning is flourishing like this. There is supporting environment also that we will see little later. And data mining is one area where machine learning has got its space. Data mining in the sense we have a huge amount of data. We have to extract only relevant data from that. Based on the data, you take a decision. If this task machine can do, then it is scientific data mining or automated data mining or something like that. So one simple example, if you want me to quote, on what basis items are put in supermarkets on the racks. All of you might have gone to Spar and this More and many Lulu Mall. So many malls are there. You might have gone to, or you might have visited them. On what basis items are kept in the racks?
Sir, the people who are visiting, their preferences, like kids are there. As soon as we come, chocolates and other things, juice, all the attractive things. Groceries at the last.
Okay. For DMart, groceries in the beginning.
On the basis of past history,
Good. What do you mean by that, sir?
means
Past history of whom?
past history of customers buying the products.
Yes. Yes. So one who has taught or learned data mining, data warehousing, you have a concept called as market basket analysis.
Exactly.
Yes. So what it says is just to study the purchasing pattern of any visitor to this mall since last 1 year. Every day, lakhs of people are visiting that mall. Each one of them, whatever they want, they purchase. If we study all these bills, then you come to know that 20% of the customers always purchase sugar and something else like a milk together. Milk and sugar you may not purchase together. Just I'm giving one example. Then if you keep milk and sugar side by side, probably they are lured to purchase both of them. That is the reason why while we go to these malls, we go with the purchase of purchasing some 20 items. And while we come out of the mall, how many items we have purchased? Less than 20 or more than 20? Or exactly 20?
It could be more than 20.
If you purchase exactly 20, then you are very big control of yourself. Normally, if you want to purchase 20 items, then by the time you come out of the mall, it will be 60, 80, 100 items. There are so many other things also. One buy one, get one free, this concession, that concession, discount, all those things. But the way they keep the items on the rack is based on this analysis of all the bills which they have since last 1 year. Do you think human beings can do this analysis very easily? 1 lakh bills a day, and in 1 month, 30 lakh bills, and into 12, those many bills I'll give to one person, tell him that I'll give you 1 lakh salary, analyze them, how many of them have purchased together item X and Y. Is it easier task for us? We don't say that it's a difficult task, but it's a very mundane task, needs a lot of concentration. And what is the solution about outcome? We will be lost after some time, and there cannot be, or there might not be efficiency also the results what we get or what we give if we use human beings for this. But very efficiently computers do these kind of tasks. So now the data processing needs are very high. Very high. How many, on what basis a pear soap company produces pear soaps and transports them to Gulbarga district every winter? They will have past years, past 10 years data, 20 years data. There's a machine which processes this and tells that slowly users of pear soap in Gulbarga region during winter is reducing. So based on that, send only these many boxes, don't send these many boxes. This kind of data analysis was out of our capabilities earlier, just 20, 25 years before. All these things people have to do manually, which was very, very difficult at the time. Those who are very efficiently able to do this, they flourish in the market. Other people, sometimes they used to produce very high quantity, there's no market, loss. Sometimes it's a huge market, there's no production, loss. Like farmers, still this mechanism has not entered into farmers. This kind of analysis, market basket analysis, has to be done for farming. Then you know in which season what fruits are purchased by how many people. Unpredictable. Fine. Now the needs are like this. And there are many things where human behavior has to be mimicked. That's what we have now. Robots. People are not happy marrying another person now. They're happy marrying robots. Because they want, in many applications, people want now human mimicking systems, models. So these are all the needs for us to think that machine learning is essential. But why now? Why did it not flourish around 15 years before? Whether researchers were not there? Who can research on this? Why it flourish now? The reason is now we have a huge amount of data. As I was discussing earlier, data is essential for any machine learning algorithm to work efficiently or to generalize the contents. So now availability of data is very high. I had given one project to one of my students when I was in Bagalkot in 1990, 98, 2000, something of that time. The task was very simple. Classify the flowers and name them based on their appearance. That time smartphones were very rare. Everyone had not got the smartphones. So to collect a data set, that person has to roam around different gardens, different places to take a photograph. Digital photography also was not there. And he could collect 100, 150 photos, and based on them only he has to do his research. But now things are different. If there is one nice Brahma Kamala in my courtyard, then night I take, normally Brahma Kamala blooms blossoms completely around 12 o'clock, 1 o'clock in the night. Then I take a photograph, write a nice quotation quote at the bottom, probably with my name also. Then with a good morning message, I will send that photo to all people who are my contact. And seeing that, again, they will forward that to another list which is in their contact. Likewise, anybody who has got flower in her or his place, all those flower pictures are distributed to everyone. So this person who wants to do this kind of studies need not have to go to gardens in search of flowers. He can get the image of a flower which has happened or which has blossomed somewhere in Europe, Germany, America, without any much effort. So this way now data is automatically being collected and stored some form or the other somewhere in this digital world. We need a high amount of data, but data is automatically being collected. Only thing is we have to take it and we have to formalize it, pre-process it, and collect it based on my need. Then I have to process it. That's what very recently there is one very popular field of research, sentiment analysis, social media analysis. To do this sentiment analysis, social media analysis, you need not have to collect any data because already you are member of Twitter, you are member of X, you are member of WhatsApp. Many people send you the message. Only filter those messages, separate them, and use them whatever you want to decide a sentiment of people. So huge data we need, and the data is available, automatically available. That's one thing. Then if you see again Moore's law, computational power that we are getting now is very high. GPUs we have. Earlier, when we studied our BTech in 1990s, early 90s, we studied 8086 microprocessor. 8086 microprocessor, the earliest microprocessor where commercial microcomputers were built around that. Do you know what is the RAM capacity of the 8086? Do you remember? Majority of you might have studied that or still teaching that. I don't know whether you teach 8086 now or not. What's the RAM size, addressable memory size of 8086? It was Intel microprocessor. You have to be fast. Only we are running short of time. I have not started speech processing at all.
1 MB, sir.
1 MB, very good. Very good, correct answer. Do you teach that subject, sir?
Yes, sir. Already it is.
Okay.
Previously, I
Taught
teach that
that.
subject.
Okay.
Not
Now,
now, sir.
yes. There were 20 address lines in the address data bus of that 8086. 20 address lines, 2 to the power 20. 2 to the power 20 is 10 to the power 3 and 10 to the power 3, 10 to the power 6. So 1 MB. Can you think of 1 MB RAM machine today? Today RAM size is 8 GB, 16 GB, 32 GB. Still that is not sufficient to our students. They always complain. So there's a huge growth, tremendous growth in computational power, which is essentially required for machine learning applications. So that is what there's increasing support from industries in the form of funding, in the form of research grant, in the form of workshops. So you have resources like a data, you have resources like computational power, you have many algorithms are developed by the researchers, new algorithms, and you have support from industry also in terms of finance. So this is the right time for it to flourish, and it has flourished. That's what you have generative AI now. ChatGPT takes certain information, extracts information from this, it generates a new thing. That's what now there's no job for code developers, basic code developers. All code is developed by machine itself. So some important tasks where machine learning is used are pattern recognition, generating patterns, GenAI is what we call them as, recognizing anomalies, differences. What's the difference with this pattern, prediction of something, what happens next year this time considering rainfall, prediction. And now, though car is a product of an automobile industry, majorly it works based on the inputs from its sensors. Earlier, if you take a car to your garage, if Mestri is expert, then he could identify what's a mistake and he could do that. Now, do you know how diagnosis of a fault in a car is done if you take it to a garage or showroom?
Scans of them.
They use software, they connect a laptop to one
Yes.
part of your car and it will check whole circuit, tell that this part is not working. Now service means remove that part and put a new part. There's no concept of service. So to this level, things are developed. Coming to some basic concepts, which already you might be knowing. So here you have some red dots, blue dots. If you assume that these two are the classes, then there's one line which is shown in between them that separates red dots from blue dots. This line separator is known as classifier. If I say classifier is y is equal to mx plus c, then it's a line which separates them into two groups, two parts. That's a classification task. Right? It's as simple as that. If line is separating, then it's called a linear classifier. Right? And is there only one line which separates them? Is there any one line which separates these two classes of points, red dots and blue dots? No. There are many lines which are separating. Then which is the best line that separates them? How to know that? Or just by your general understanding, how to decide the line that is best for classifying two groups of objects? Anybody give some answer?
The one
Using
which
shortest path algorithm.
One of you can tell. Sudharani madam, what is the shortest path algorithm? Where is the path comes here?
No, sir, not path. Like I'm saying, in order to connect the two objects, so we need to like find out the shortest path, which will be connecting those two objects.
Correct. No, but what we are talking about here is classification. Line separates them, we know that. But there are many lines. Some 10, 12 lines I have drawn which separates those two sets of points. Which line should we take as a classifier?
so the one which gives the least number of mixing of both.
No, all these lines are not mixing any points. They are totally separating red and blue points. You can check there. There's no mixing. Any other improvement on the answer? What you're telling is right, partially right. One thing I want to tell here, whenever you put one line and say that this is a classifier, this line is not only for the given points. After some times, unknown point is going to come. That unknown point also should be properly classified by this line. Either it's in the blue group or in the red group. What we are seeing now is a training part. This is a data given to me and say that this is one group, so put one line so that they make this classification, is already known to me. When an unknown point comes, that has to be put in a proper group. For that, we need to follow certain criteria to decide this line. Normal criteria is take that line as a classifier which is at the equidistant from the nearest points in both the classes. And the point should be at the equidistance from the nearest points to this line in this class, so that whenever a new point comes, there is more scope for that new point to be able to classify properly by this classifier. Are you getting what I'm trying to tell? So a line, whatever line I'm going to draw here, should be at the equidistant from this blue line also and this red line also. So that's a fair classifier. If I draw one line which is more nearer to red dot and farther from blue dots, and probably further if some red points come slightly away from this, then that will be classified into blue dots. I hope you are getting. So line that we are going to decide should be equidistant from the nearest objects. This is a line which is, this is got with some distance with blue dots, with the red dots also it's at the same distance. So take this line as a classifier. So if some other points also come in this region, they are classified as the blue dots. If some points come in this region, they are classified as the red dots. Fine. SVM does classification this way itself. This is simple maths which we had studied in our primary schools. Y equal to mx plus c, which is dependent variable here. Y equal to mx plus c. How many variables are there in this sentence? I mean this equation?
Two variables, sir. Y is dependent variable, X is independent variable.
Y is dependent variable because it depends on the value of x.
C is constant.
C is constant, M is also constant.
M is slope, sir. That
M
is
is slope. That's what.
yes,
For a given line, it is constant.
yes, sir.
M is the slope which is obtained by dy by dx, change in y by change in x to the particular line. And C is its y-intercept where it cuts y-axis. What is the C-intercept of this line presently, which you are seeing on the screen? Is it positive or negative?
Positive, sir.
No,
So,
mx plus C. Value of
mx
C I'm
plus
talking
C.
about. C is a y-intercept, isn't
Okay.
it?
Yes, sir. Yes, sir.
Y-intercept means where it cuts y-axis. It cuts y-axis down, isn't it? Fine. So M and C are constants, X and Y are variables. Y depends on X, so Y is independent variable. Y is dependent variable. X is independent variable. So we change value of X and accordingly we compute value of Y. Fine. See here, one more kind of a thing. Just all machine learning algorithms learn patterns of points. These points are spread here. This pattern we have to catch. In which pattern they are spread. Two people have drawn two patterns here. One is a line, red line. Other one is a green curve. Two curves are drawn to represent this spread of pattern of points. Which one is more realistic curve here to represent this pattern? Green curve or red line? I hope you have understood what I'm talking about. Now my aim is to draw one curve which fairly represents this spread of points, this pattern of points spread. To represent this spread, two people have drawn two curves. One is green curve, another is red line. Which out of these two represents this pattern of points in a better way is a question.
Green one, sir.
Green one represents better way. Why? Why not red one?
Because it's cover all the points.
You see the spread of blue points is also curvy in nature. It is not straight line. Straight line, of course, may be approximated to represent this pattern, but better approximation is this green curve. So green curve represents given points, and a red line also represents, but it does not represent as efficiently as the green curve represents. So better one is green, red one is less preferred. Okay. Just I wanted you to understand this because later we may use this. So here you see one, again you have been given a points here, but in this group of blue points there is one red point, and in the group of red points there is one blue point. And if you are asked to decide a classifier for this, if we say that linear classifier is to be used, then this line I will draw. Is it a perfect classifier? This classifier line is keeping all these points in one group towards left, all these points towards right into another group. Is it a perfect classifier? Keep speaking. Perfect means there is no error. Is there error in this or not? There is an error because this red dot is classified as blue dot, and this blue dot is classified as red dot by this line. So this line is not a perfect classifier. In the real world scenario, deciding a perfect classifier is very difficult. We can approximate. Some misclassifications will always be there. We call them as errors. So this also has got an error. So this is not a perfect classifier. See what happens next. I have one more classifier. This classifier keeps all red balls in one side, all blue balls in another side. So is it a perfect classifier? Yes or no? No answer. Keep telling things. You don't worry whether they are right or wrong. Is it perfect classifier or not?
Sir, it is a classifier, but it is overfitting.
It is a perfect classifier. Fine. What do you mean by overfitting, sir?
Because it is covering all the data points. Because this becomes, I think, it become going to be a very complex. Because each and every data points it is classifying.
Classifying, correct. But if each and every data point is perfectly classified, do you want to say it's overfit?
Yeah, because it becomes complex, sir. That what I understand.
No. For this example, it is fine.
Yeah,
But
yeah.
if you see this example here, all the things are properly classified by line also. No, is it overfit?
But it was not linear. Here it is linear.
Fine. Linearity is simplicity and complex. This one is a complex one. It's a complex classifier, and this one is a simple classifier. Fine. But I'm talking about overfitting. What do you mean by overfitting?
The points are very far from that lines. Most of the points are
Where here,
here near to that line.
near to the line, here they're not near. Here also near, no? These red points are near. Only this red point is far. This blue point is little far. We'll come to this clarity a little bit later.
Yeah,
But
yeah,
what I
sure.
want you to understand now is this is a non-linear classifier, which is not like a line. Finally, classifier has to be taught to computer by giving its equation. If circle is a classifier, you have to give equation of a circle as a classifier. X square plus y square is equal to r square. If line is to be a classifier, then y equal to mx plus c. Line equation has to be given as a classifier with proper values of m and c. But here, if you want to give equation of this curve, which is exactly classifying them. Anybody is from the maths department?
No, we are not from maths.
Okay, but at least you can guess what will be the order of the equation of this curve
Uh,
roughly?
roughly, I can say it is not less than 15.
15. Good. On
Yeah.
what basis it is done?
So it may be the polynomial of order 15, it may be.
Yes. If it is a line, y equal to mx plus c. What is the order of this equation?
I think it
It's
is
1.
simple.
It's 1.
It's always one.
It's 1. 1. Order is 1. Order is the power that we write.
Yeah, yes, sir. That's it.
If it is a circle, x square plus y square equal to r square, or a parabola, one turn is there. Circle. One what is called as some significant moment or something. I forgot that word. So if one curve is there, then the complexity of the equation will be incremented to a next level of its order. Circle is the equation of order 2. If there is one more turn, then that equation becomes 3. One more turn, 4. How many turns you have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, 13 turns are there.
Yeah.
And if you want to represent this turn by a single equation, as sir said, it may be of order 15, 14, something like that. Quadratic equation we have solved in the first year, isn't it? We have taught that to students, quadratic equation, these many solutions, real solution, uh, uh, different kinds of solutions we have done, isn't it? Quadratic means 2, order 2. Order 2 equation is so difficult to solve. Think of solving order 15 equation. It's very difficult. So this one is a complex classifier of these 2 points. Many times we may have to take trade-off between classifier being very complex and classifier being efficient. Here, this classifier is fine for us. It is doing some 2 misclassifications, but those many errors we can handle. It's not a big task. But here there are no errors, but classifier is very difficult. That's what it is said. 0 errors, complicated model. 2 errors are there. Still, it's a simple model to implement. Computational cost is very less, and you get better results. Let there be 1 or 2 results, not 2 errors. This is called as satisfying solutions, not optimal solutions, but satisfying solutions. Optimal solutions, the best solution. Getting the best solution is always difficult. Optimal solution is difficult. Satisfying solutions, fine. Okay. So in machine learning also, whenever you want to decide a pattern for a given images or whatever, you need to go for a satisfying solution, not complex solution. Now let us discuss this underfit, overfit, and all these kind of things. These are funny examples which remember all of us our marriage days. Almost all male participants of this group, I suppose you have stitched what those blazers in your marriage, isn't it? Blazers in your marriage. So what is the fit of the blazer? Is it perfectly fitting like a tight shirt? Did we stitch it like that? Yes or no? I doubt whether you have stitched
No,
blazer.
sir.
No, no. But answer, madams are giving. So what about male candidates? But normally, madams only stitch blazers for their husbands.
Sir, many are replying in chat box, sir.
Chatbot I'm not able to see here, madam, because this is full screen, no full screen mode. If you go to chat box again, this has to be minimized or something like that. No problem, no problem. Some of you can speak also. If you speak, it will be good. There will be interaction, and others also can hear that. They can contribute to that. Normally, we will not go for very tight fit because after marriage we don't know what happens if wife takes care a lot of us and every day gives very good food, then we may grow horizontally, isn't it? So this blazer might not be useful after 1 or 2 years. So little loose we fit, and we will not fit it very loose. Not fit it very loose as in case of figure 1.
Yes, sure.
Normally in our olden days, once we were very young, if some 3-4 children are there at home, if parents go for purchasing dresses for Deepavali or something like that, what kind of dresses they used to purchase for us?
That's at least it should go for another 3 months, 6 months.
Not months, sir, it is years. Another
Yearly.
3-4 years we should be able to wear that. So such loose shirts they used to purchase. As they are very loose, we will not wear them for next 1 or 2 years. By the time after 2 years they will be old, so we will not use them. So that way it used to be. Fine. Either very loose or very tight. Both of them are not useful. Very tight one, it's perfectly fit. Perfectly fit. Overfit. The tailor takes the perfect size of your body, your stomach, your shoulder and everything. He does stitching. And on that day you can use it even not very comfortably, but it is as per the dimensions of your body. But here, dimensions are not at all considered. This it's a free size. Free size dresses are there, no free size. You can take it and use it. Both of them are not good. This is more generalized version of any body. This is a very specific version of a given body. Very specific version, no use. Your brother cannot use it. Even you cannot use it after 1 month or 2 months. This one, anybody, anytime can be used. Middle one would be a right fit. We're not talking about that. First, previously we were discussing overfit. No, overfit means it is learning only those given example. This blazer is suitable for only this person with that measurement. If after 2 months slightly a measurement of the stomach changes, it will not be useful. Means whenever an unknown data comes, this blazer will not be able to fit and it will not be able to classify that. Because it has learned only what you have given, that dimensions, parameters, stitching parameters. But this has learned everything. This has learned everything. Even double the size of me also can wear this. I want to relate it with another example. Normally, once we take the classes, after taking all the classes, we ask our students to prepare well for the exam, and before exam, we give them some questions. Concentrate on these questions. Prepare them well. 8 questions used to come in the exam, and we give some 15-20 questions to them and ask them to prepare on this. Whether all the students prepare these 20 questions?
Not necessarily.
Not necessarily. They prepare only 8 questions, thinking that if I am able to solve 8, it's good. I will clear that exam. Still, they are hoping better marks in that because all 8 questions I want to solve. Some people still prepare only 5 questions. 8 questions are there, 5 we have to solve. Choice will be there, so I prepare only 5 questions. Some people want to pass only, so they prepare only 2-3 questions. Whose preparation is better? The person who studies all 20 questions or whole syllabus or only 2-3 questions?
I think the person who has studied few questions and passed the subject is, I think it is good.
If the aim is to pass.
Yeah.
But real life is not like that.
Yeah.
We have unknown questions. Even we do not have syllabus. So if a person studies only 2 questions, 3 questions, 4 questions for the purpose of passing the exam, then it's forfeit. He doesn't know anything other than those questions. If question paper pattern is little changed, if questions are changed, then he cannot pass. That is forfeit. He prepared only for that situation. On the other side, underfit, he has studied everything in that subject. Everything in that subject, focus is not there. Again, efficiency is not there. This is underfit. Underfit is also dangerous. That's what, while designing, while taking these lines, this red one is underfit. This green one is proper fit. Later there are some slides, it seems. I hope you have understood this concept of
Yeah, sure, sure.
So see here we have 2 sets of points. Bottom, we can take bottom example, which is more clear. We have green points and red points. I have one classifier. I want to use line as a classifier to classify them. I want to use this curve as a classifier to classify them. I want to use this perfect curve which exactly separates all green balls to one side, red balls to the other side as a classifier. This perfect line curve, which has got very complicated equation, is not necessarily required in real-time applications. On the other hand, this is very generalized classifier which may classify them if you properly orient their slope and y-intercept, but very generalized one. Instead, if you put this parabola kind of a thing, though it does certain misclassifications, wrong classifications, it is comparatively better, which can take care of new points which are coming into the classification. So this is a good fit, good model.
Yeah, definitely, sir.
This is an overfitted model. This is an underfitted model. So based on a given data, you need to decide which model is good for you. That decides efficiency of your machine learning algorithm, not randomly using some models. So for that, we have many statistical techniques to study the behavior of the model. So probably it may be difficult for go through all those things now. You have exam also, I suppose, as Madam reminded me at 6:30. So we will stop now. I have given these PPTs to Madam. If you want, you can take them and see them. In case if there are any discussions we can make also, consult me through the organizer, Jayashree Madam. So we will stop now, Madam.
Sir, is there any another 5-10 minutes if you wanted to take, then you can
Yes, I
also.
can take, no problem, Madam.
And
Tell
if
me then
any
whenever I
important,
have to stop. I will
no,
continue now.
actually it is time is over, sir,
Okay.
at 6:30.
Huh.
But if anything important is left out, so we can start afterwards. After this, we can start the test, sir.
Okay, then another 10 minutes we will discuss.
Okay, sir.
Another 10 minutes, 10-15 minutes we'll discuss, then we can go for a test.
Yes, sir. Yes, sir.
So
Yes,
one
sir.
more thing you also might have heard about, the k nearest neighbor problem. Means we have some groups of items. Whenever new item comes, you have to classify them to which group it belongs to. In this particular example, you have some white and black balls, you have some chocolate balls, and you have some green colored balls. Those are called as footballs, basketballs, and tennis balls. Whenever a new ball comes, this black ball, unknown ball, we don't know to which category it belongs to. We need to decide now. To which category this black ball depends. How does a k nearest neighbor performs? How does it do that? Anyone has got any idea?
Sir, I think randomly we can select that point, some point, we have to calculate the distance,
Okay.
and then depending upon the features which we distance measure, we can I think sir,
Yes.
we
Yes.
can
Similar to that. I will put it in a different way.
yeah.
Making this new ball which has come, whose class is not known, as a center, you draw one circle, equidistant circle, and you check how many footballs come into that circle, how many basketballs come into that circle, how many tennis balls come into that circle. Whatever number of whatever type of balls come in more number, you can predict this ball belongs to that category. Easiest way. So here, one football has come, one basketball has come, but 3 tennis balls have come. So put this into tennis ball, category of tennis ball. And majority of this machine learning algorithms are approximation algorithms. That's what we call it as prediction. It is not perfect classification. Perfect classification is not possible. There can be errors. So here, this black unknown box can be categorized as tennis ball. Fine. This is K nearest. Sir, Nagendra sir, any question you want to ask?
Yes, sir. One thing just I want to know, what will be the optimum value of the K we should select here?
No, K nearest neighbor you need that depends upon whether you want to make your model more generalized or very specific.
More generalized, sir.
Generalized means your radius should be very high.
Okay.
Radius should be more. If whether it is more or less, finally what you will be doing is you will be counting how many particular kind of balls fall in that circle. So based on that only we will be deciding.
Yes, sir.
So it doesn't make much difference. But if you want the model to be more generalized, you have to underfit. More underfit, then you have to take the larger sized, larger radius circle. So then some speech aspects I want to discuss. Speech is a very interesting area and very interesting skills that human beings have. It is learned over the years. Even today, many times, if somebody is speaking, we keep hearing those speeches and we feel like hearing those speeches more and more, especially some very good public speakers. We feel like not stopping at all. Sadhguru's speech, Modi's speech, Kumar Biswa's speech, some good people speak, then we keep on hearing their speech. It's because it's a acquired skill, practice. People do that, but lot of technical things happen at the background. Even once we make machines understand the speech and produce speech, its technicality has to be more precise. So there are many issues in speech processing. One is speech recognition. Speech recognition, since given a speech, we need to convert that into a text. Your computer should hear to somebody's speech through a microphone. It should do that processing, convert that into text, and all these Google applications and all those things you have seen. Whenever you keep speaking, equivalent text keeps coming. That is almost a solved problem. One more is speech synthesis. Given a text, computer should generate a speech. That's also there. Still, 100% it is not solved for all the languages, but people are working in that area. This is speech recognition, speaker recognition, speech synthesis. Apart from this, there are many applications. Speaker recognition is there, gender identification is there, age identification is there, then language identification is there, emotion identification from speech is there. So many applications are there. After this mobile phone became very popular device, then speech applications have become more popular. The huge scope for doing research on this speech. So I'll not go into the details of all these things as we do not have time. But what we are doing recently in our lab, that I will discuss this one or two slides, which may be helpful to you. So we call them as sustainable technologies because whenever speech processing is a very old concept, maybe some 35 years old concept. People start working on that. So in this speech processing, we had certain kind of features. Because of computational flexibilities of machines today, speech feature extraction techniques are also very powerful. So using these techniques, I call them as sustainable feature extraction approaches, sustainable speech processing approaches, and those can be used for different applications. One such application was, we had one DST project called as phonology analysis from children's speech. Phonology analysis. Phonology means the way child learns speaking. All of a sudden, immediately after birth, probably after 2 or 3 months of birth or 1 year of birth, child cannot start speaking every phoneme or every word, every language. Always the child has got certain limitations. Some features it learns in the early ages. Some features child learns in the later ages. So this process of learning pronunciation of phonemes in different languages is known as phonology. We had studied this phonology in case of Marathi and Kannada for PhD students. Then what we did here was, we had studied the pronunciation of r and d, r and r. Or this is actually vowels. This is not r and d. Before that, we did this. Different vowels take different positions in the scatter plots. These are scatter plots which are drawn using F1 and F2. F1 and F2 are frequencies. Using frequencies, if we draw at the different ages, age groups, we have different clusters of these vowels. Means children will be able to pronounce vowels at the time they attain the age 6 to 6.5 years. This is the last image. This A, B, C, D. D part, where proper clusters are there, very clear clusters are there. But here we have not got sufficiently well-defined clusters. So vowel pronunciation children attain at the age of 5 to 6.5 or 7 years. That this study shows. Similarly, I was telling no r and d pronunciation, r and r. So there we have very clear distinctions between two pronunciations. Based on these things, we can decide whether it is properly being pronounced or not. Likewise, this one study, they had used different features: MFCC, smell frequency, capsule coefficients, linear prediction capsule coefficients, glottal closure distance, and the classifiers what they have used are random forests, support vector machines, and they could classify male and female children classes. Deciding male and female from the adult voice is easier, because human beings also can very easily recognize it, who is male, who is female. But in case of 3-4-year-old child, deciding what gender of the child is very difficult. So these features are used and these classifiers are used, and this outcome they got. This is again gender classification with higher level classifiers like neural networks, deep neural networks, and all. One more work which was done is this called as scene classification from the speech features. So normally once we are in a particular situation, scene, our machine should be able to recognize that. Say for example, if I take my mobile phone itself as a machine, if I enter into meeting room, it should sense that meeting room scene, and automatically it should turn into silent mode. If morning, if I am in the garden, then it should give me some suggestions regarding whether I should go for a brisk walk or normal walk or whatever. So these are called as smart digital assistants. That work related thing it is, where here we do scene classification. He also has used different features here. Some scenes are shown here. One is a metro station is one scene. City street is one more scene. Park is one more scene. If scenes are coming one after the other, they are called as isolated. If they are coming overlapped, then they are called as polyphonic scenes. So some features they have is don't worry about all these features. And they have got around 99% of the results using some specific features like bag of audio words and support vector machine classifiers. So we also have got one publication from out of this. It's InterSpeech. InterSpeech is very prestigious conference in speech. And similarly, this is using some advanced classifiers like convolution neural networks, deep neural networks. Much about that. And Spurti V was one more PhD student. She continued the work and she mainly concentrated on polyphonic sound separation. So she did that. This represents a polyphonic sound events which are overlapped with the other sounds. And also rare sound events they process. Rare sound events in the sense night around 12 o'clock from some part of the city, some road, some accident, break skiing sound comes, or a woman screaming, woman or a child screaming sound comes, or a gunshot sound comes. Then that should go to nearest railway station, and railway people should be alerted from this part some untoward incidents are happening. So those actions can be taken immediately. Such work was done. So these are some such things. Don't worry about much of these things all. So what I want to show is how the developments in speech processing are becoming more and more sustainable, and those things can be used by anybody else for speech processing. So we got very good results, above 90% results in all these kind of cases. Fine. So we don't have much time. Speech processing is very important area. So we have many issues in that. We need to explore all the options and go for speech processing applications. If there are any one or two quick questions, I'm very happy to discuss. Please.
Thank you much, sir. Just the general questions that
Yes, sir.
I
Yes, sir.
want to ask you. There's so many things that you have done in the speech processing, but I also heard that since 30-35 years, it is still a challenging
Yes, yes.
area for of the research. Sir, whether the data or the your acquisition of this data is being done in the lab, or you are making use of the data which is available on the internet, and in connection with this one, is there any open source for acquiring this data, and then we have to do the projects and all that in the
As I
institute?
said, it is an era of abundant data.
Yeah.
And in Indian context also, central government initiative has collected many data sets. IIIT Hyderabad has collected many data sets. There was one initiative by central government called as TDIL, Technology Development for Indian Languages. There on many languages, data sets are already collected. Those are freely available either at the DST or at the places where this research has happened. But majority of the times, data collection is research oriented. Why I want to collect a data set? Based on that, data is collected. Say, if I want to collect a data for identifying emotion of a person, then that's a different data. It has to contain some emotional content into that. If I want to identify speaker, then speaker features are to be more prominently available in that data. Then it is age. Then we need to choose a samples based on age groups. So generally data are available, speech data are available. But if it is a very specific application to get and show better results, specifically collecting data set or preparing data set from the available data set is essential. So that we need to take care. Data preparation is finally with the researcher, because any random data set we cannot use for all applications.
Thank you, sir. Thank you.
There any questions?
Sir, are you working anything classification of the disease based on the voice collections or the voices?
During COVID, we have worked, sir, but it was not a very full-fledged work. Small conference paper we had on that. we wanted to decide whether a person has got COVID or not based on his cough sound or his
Yeah.
speaking sound.
Mhm.
But that time getting data set also was difficult because there was isolation. We cannot go and record and all these kind of things. But still, we have one class of disease known as ILIs, influenza-like illness.
Okay.
COVID is a part of that. COVID and all this cold and cough are the part of that ILI. ILI, we had done it. Means
Okay.
collected data set from such people, and based on their voice, we will be able to decide whether person has got any throat infection or any viral disease, viral fever, and these kind of things. That can be done.
Thank you, sir. Thank you.
Yes. Jayashree madam, go ahead. Thanks for an opportunity